This is Daniel Hayes with UNC Charlotte, Department of Electrical Engineering Technology, and I'm going to show you a quick tutorial on a 1-second blink LED code using Assembly. We're going to do this through Studio7, which can write directly to the microprocessor and not using the Arduino IDE. We can do this with C language. We can also do this with Assembly. We're going to do this example in Assembly. So the first thing we want to do is we want to come up with the 1-second loop code, because Assembly language does not have a built-in delay or any kind of function like that. So I've got a 3-tiered loop code written here, and I'm going to load in the hex 1 3 times just to get a base for how long this cycle count is going to take. So if we come into here and we stop the build code and start it again, we can see that the cycle counter is 9 cycles or 9 microseconds. The ATmega 2560, which is the processor that I'm using, runs at 16 megahertz. So for 1 second we need 16 million cycles, or 16 million microseconds. So we can see that loading in just one hexadecimal in each loop gives us a cycle count of 9. So we're going to take this and we're going to increase it to FF, which is the maximum that we can put in this register. And we'll stop the build code and we're going to restart it and let it run, and we can see now we've went from 9 cycles to 771. So that's still a long ways away from our 16 million. So since that's the most we can do on this loop, we're going to add FF to this loop, and we're going to start this again. It'll take just a little bit longer to run. Alright, so the code is finished running, and we can see that we're up to 195,843. So that's getting closer to our 16 million that we need cycle count. And so what I'm going to do is just take my calculator and take 16, let's see here, calculator. And we're going to do decimal 16 million. Oops. And divide that by about 195,000, and looks like we get 82. So we come up with 82 loops. That's in decimal, so if we convert that to hexadecimal, that comes out to 52. So basically our 1-second code is going to be about 52 on the 3rd tiered loop. So now that we've got our 1-second loop code figured out, we take it into our main code and we're going to put it in here, and we should have a 1-second blink, 1 second on, 1 second off. So the code, as far as what it does, we have an LDI, which is a load immediate instruction. Into register 16, we're going to load binary 1, 8 bits. We're going to set up port A as an output, and it's taking in this 8 bits and setting bit 0 to an output using the register 16. Here's the start of our infinite loop. Again, load immediately into register 19, binary 1, output port A, register 19. So we're going to assign this binary number to port A, which this is going to assign bit 0 of port A to a high. After this, we have load immediately register 22, 21, and 20, just so it don't interfere with these registers, and we can get them all on the line. One thing I forgot to mention was the BRNE instruction, which is branch not equal, and basically what it does is if the previous branch does not result in a 0 flag, then it will jump. We've got it jump into our loop labels, but once it does equal 0, it passes through to the next line. Here we have, we're going to set the LED back to low, and we have our 1 second loop code that we recycled from up here. One thing to notice is make sure that we rename the loops here, the labels. And finally we have jump to start at the last instruction, and we can see here our label here is start, and we're going to start this process all over. So it's going to blink on for 1 second and off for 1 second as long as the board has power. So to output this to our microprocessor, there's two ways to load this to our board. One is to use the command line, which works fine, but I prefer to use the built-in external tools. You come in here, you can go Google on how to set up this command and the arguments and everything. And I've got my Mega set up on COM8, and what we're going to do here is once we're ready, editing, I'm going to rebuild this. Debug mode. Okay, so I've rebuilt this, and now I'm going to upload it to the board. But before I do upload it, I would like to go over one more thing. I know I was talked about port A and bit 0 of port A. So basically, port A is a parallel port. So there's 8 different channels for this port. And I went to Arduino.cc and went to their pinout and see port B. So this allows me to figure out which pin I want to use to hook up the LED to. Here we go. PA. So they're short for port A, and we can see that bit 0 is right here, and we can see that it is tied to digital pin 22. Therefore, we're going to set up our LED power source from pin 22 on the board itself. Okay, so we've got it all wired up. I've got a 1 k ohm resistor hooked up to the LED to limit the current to about, I want to say 5 milliamps. I believe it's a 5 volt output. So 5 volts divided by 1K is 5 milliamps, just so we don't burn up our LED. And so let's upload this code using our external tools, which we've already set up. And here we go. It's set up, and let's check this out and see if it works. So as you can see, the LED that I have hooked up is blinking approximately 1 second, and there you go.